Okay, in this video we are going to see if we can make a vector of the squares of values from 1 to 2 in increments of 0.1 using indexing. We're still doing indexing. Okay, so the vector would look something like 1 by increments of 0.1 to 2. So let's not forget our clear CLC. Okay, so run section. So that's what our vector would look like, and then we want to square all those values and make another vector. Okay, that's not going to be very easy doing what we did in the last video, right? Because we can't have bucket 1.1 or bucket 1.2. Okay, so what we're going to do here is actually the most general way to use indexing to, say, turn one vector into another vector that depends on it. Okay, so what we're going to do is something like this. We will say for n equals 1 to the length of our vector. Okay, so n is going to take on the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because we have 11 elements in our vector. And then we'll say new vector element n will be the old vector element n squared. And then we would end the for loop and probably want it to print out new vector for us. Okay, so first time through the for loop, n will be 1. New vector element 1 will be vector element 1 squared, so that's the 1 squared would be 1. Second time through the loop, n would be 2. New vector element 2 would be vector element 2 squared, so that would be the 1.1 squared, whatever that is. Alright, and so on. Okay, so let's run this section. So let's see, 1 squared is 1, 1.1 squared is 1.21, 1.2 squared is 1.44. If we go out to the 11th element, 2 squared is 4. Okay, so that looks fantastic. So, like I said, this is the most general way to create a new vector. We are actually indexing into the new vector and indexing out of some existing vector, right? So we're kind of doing, we're putting in and we're pulling out to make this happen. We're also making use of the handy length function, right, so that we know what n should end at. So it's going to start at 1 because that's our first bucket number, and then the last bucket number will be the length of the original vector. Okay, so just really quickly, this approach means that we could do any vector at all. Okay, so our vector could be 2, 5, 37, 59, 2,345. Okay, and if we wrote our for loop like this, for n equals 1 to the length of vector, and new vec element n is equal to vector element n squared, and then look at new vec, we should get the squares of whatever random values are in vector here. Now, it's really important that you don't forget to index on both sides, right? So again, we're indexing in and we're indexing out. So let's run this and then maybe we can play around and see what happens if we don't type the code properly. Okay, so run section. There's vector, here's new vec, all those values are squared. So let's say we forgot to index in and we just said new vec equals vector element n squared. Okay, so now new vec, first time through the loop, it squares the 2, sticks it in new vec. Second time through the loop, n is 2, it grabs the 5, squares that, and sticks it in new vec. So basically it's overwriting, right? Because we didn't specify a different position. So new vec ends up just being a scalar, and the final time through the loop, it grabs vector element 5, the 2345, squares that, sticks it in new vec, and that's what new vec ends up being, right? So not a vector at all, not what we wanted. So let's go ahead and put the n back in. And if we tried to do this without indexing out of vector, of course we would get an error saying you can't use caret with a vector. It would have to be dot caret, but then all kinds of problems, right? So moral of the story is just don't forget to index in to the new vector or to index out of the old vector, or what you want to happen is not going to happen. Alright, great. That's the end of this video.